Hey there! Today we're diving into a data processing problem that involves migrating code from pandas to poolers. The issue at hand is with the cut function in poolers, which behaves slightly differently than in pandas, especially when it comes to the labels. Now, let's talk about the solution to this problem. In the provided solution, the first step involves creating a data frame in poolers and defining the desired breakpoints and labels for the cut function. By specifying the breakpoints and labels explicitly, we can achieve the desired binning outcome that matches the original pandas implementation. Moving on to the next part of the solution, a custom function, calculate_breakpoints, is introduced. This function dynamically calculates the breakpoints based on the number of bins required. It takes into account the minimum and maximum values in the dataset to evenly distribute the data into the specified number of bins. This approach ensures flexibility and accuracy in defining the breakpoints for the cut function. Continuing with the solution, we combine the dynamically calculated breakpoints with the defined labels to perform the binning operation on the data frame in poolers. By using the custom function to determine the breakpoints, we eliminate the need to rely on external libraries like pandas for this test. This streamlined approach allows for a more efficient and independent data processing workflow. In conclusion, by leveraging the capabilities of poolers and implementing a custom breakpoint calculation function, we can successfully address the differences in behavior between pandas and poolers' cut function. This not only ensures consistency in data processing, but also enhances the migration process from pandas to poolers. And with that, happy coding, and may your data always be well binned. Oh, and don't forget to like, subscribe, and drop a comment below.